Okay. Now these are the things that we'll be covering. So graph theory, you have to know what a graph, properties of graph, roots on graph, adjacency matrices, transition, matrices for graphs, trees, minimum spanning tree, Eulerian graphs, the Chinese postman problem, Hamiltonian graph, the traveling salesman problem. Correct? So these are the things that we need to learn. We need to review. We have done all this, but we are reviewing it now. Now, what is the main thing that we start with? Now, first of all, what is a graph? So, graph is basically, suppose you're visiting Paris, correct? So the roads are there, and these monuments are there. You want to visit these different monuments. So, which is the route you will take? Which is the landmark? How will you visit the landmark exactly once? Correct? So how would you like to visit this landmark exactly once? Or if you are interested in seeing the streets, how will you pass through each of the streets once? So this is the whole idea of graph theory, whether you have to visit the nodes or whether you have to visit take each of the paths which are there or the edges which are there. So what are the things that you need to remember? A graph is a graph or a network is a structure which shows the physical connection or relationship with things of interest. These are the vertices, the monuments would be the vertices, and the roads would be the edges. Correct? So these are the edges. This is an edge. This is the loop. This is a loop. Undirected graph. Undirected graph you can travel both the ways. If we are allowed to move in either direction along the edge of a graph, the graph is undirected. It's like a street where there can be two-way traffic. You can go from A to B and B to A. Adjacent vertices are the vertices which are connected by an edge. So A and B are adjacent vertices. F and E are adjacent vertices. Adjacent edges, they share a common vertex. So AB and AF, correct, are adjacent edges. Degree of a vertex is the number of edges connected to it. So what is the degree of A? Hello? Why it takes so long? Degree of A is 2. Yes, correct. Degree of A is 2. What is the degree of B? What is the degree of B?
Degree 3.
3. Degree of C?
2.
Degree
of C?
Degree of C is
4.
Oh,
sorry.
4.
3.
Because whenever the loop is counted as 2, this is 1, 2, and
I thought you circle C, that's why I thought
No, it's a loop. It's a loop which is there. Now, directed graphs. A directed graph contains arrows indicating the direction in which we move along the edges. So this is a directed graph. From A to B is a directed graph. Correct? E to A is a directed graph. Okay? Fine. And this is obviously both the ways you can go in this case. So this is a directed graph. In a directed graph, the n degree of a vertex is the number of edges coming into the vertex. So what is the n degree of A?
What is the?
N degree of A.
The number of edges coming into the vertex.
So what is the 1. Okay. What
and the out degree is also 1.
Yeah. So n degree. And so what is n degree of E? So 1 and 2. Correct? N degree of E is 2. Out degree, obviously it goes out basically. So that's quite simple. N degree and out degree. Next, this is a simple thing that they can ask you to draw. So they've given you the layout of a restaurant which is there. Draw a graph to describe the layout. So each of the rooms, you'll make this the vertex, and the passageway you'll make it the edge. Yeah. And then you need to write the degrees. I put the degrees in bracket. I mean, this is something very simple. Answer this, please.
1 is 11.
So number of edges are How do you count the number of edges? Which are the edges? You know that edges are these lines. So you count the number of lines. These are 9. Correct? The sum of the degree of the vertices. So the degree of the vertices, you do the sum of the degree of the vertices. Now obviously degree is 2 times the edges. Correct? An undirected graph has 7 vertices. With degree 1, how many edges are there? So that is, you do the sum of the, correct? You do the sum of the degrees and then you work it out.
Yeah.
Explain, now this is important. Explain why an undirected graph must have even number of vertices of odd degrees.
Yeah.
Correct? So number of vertices of odd degrees A and E. So see, A and E. Correct?
Yeah.
So 2 vertices of odd degrees. So if you have 2 vertices of odd degrees, then they'll add up to give you an even number. So overall, the sum is even. They cannot be odd degrees.
Yeah.
So degree is always even, no? Because no matter what your E is, your D is 2E. Doing this, correct? So in degree and out degree you can always do quite easily. Properties of graphs. The following terms are used to describe graphs. This is a simple graph. Correct? A graph is said to be simple if it contains no loops and there is a maximum of one edge joining any pair of distinct vertices. Correct? There is a maximum of one edge.
Yeah.
Not a simple graph as there is a loop at L. There is a loop at L.
Yeah.
Not a simple graph as there are 2 edges joining P and Q. There are 2 edges. So these are not simple graphs. Correct? A subgraph is a graph made from the subset of the vertices and edges of another graph. So the subgraph. For example, a subgraph of this is a subgraph of this. Because you can see that A, B, C. An undirected graph is connected if it's possible to travel from every vertices to every other vertex by following the edges. Otherwise the graph is disconnected. So this is a connected graph because you can travel from any place to any place.
Yeah.
You can travel from A to F, E, you can travel from A to D, you can travel from C to F, You may have to pass through other vertices, but it's fine. Now this is a disconnected graph. This is a disconnected graph.
Yeah.
A graph is strongly connected if it is possible to travel from every vertex to every other vertex by following edges in correct direction.
Yeah.
So here this is a strongly connected graph. You can travel from anywhere to anywhere.
Yeah.
Even though it's a directed graph, you can travel from anywhere to anywhere. This is not strongly connected. Why it is not strongly connected? Because from A to B you can't travel. See, because if you travel from A to D, there's no way you can go from D to C, because this is the in graph for D. This is also in graph for. There's no out graph from D. So from D there's no way to go out, basically.
Okay.
A complete graph is a simple undirected graph in which every vertex is connected by an edge to every other vertex. So every vertex is connected to every other vertex. Every vertex is connected to every other vertex. Every vertex is connected to every other vertex. Correct? So every vertex is connected. So you can go from anywhere to anywhere directly, basically. Okay? A weighted graph has numbers assigned to its edges. A weighted graph is there are numbers on the edges. These numbers may represent cost, time, or distance required to travel along the edge. The length of the edges are not drawn in proportion to their weight. So this can be the time taken to A to B, So this is on a weighted graph.
Yeah.
Adjacency table is used to summarize the weights on the graph. Like, so if you draw A, B, C, D, E, A, B, C, D, E, you write them down. Now, what is the weight from A to E is 5. A to B is 5, sorry. A to B is 5. A to E is 2. Correct? B to A is 5.
Yeah.
Like that. That's called the adjacency table.
Yeah.
It summarizes the weights, basically. The symbol dashes is used to indicate that the two adjacent vertices and that the two vertices are not adjacent. Two vertices are not adjacent. Means there's no road connecting it. There's no edge connecting it. So between A and C, there's no edge. There's no loop. Between A and A, there's no loop. For a weighted graph, the adjacency matrix will not necessarily be similar. Correct? So if it's an undirected graph, it will be symmetric. For unweighted graph, always it will be symmetric. For a weighted directed graph, it will always be unsymmetric. It will not necessarily be symmetrical.
Yeah.
Try this, let's see. Check your answers. So this is, you can draw it anyhow, no problem. The shape is not important in this. Okay. So what is the degree of vertex B? Degree of vertex B is 3. So there are 3 railway stations connected to B. Determine whether the graph is connected or connected complete. Is the graph connected?
Yeah.
What is the meaning of connected?
When every single, you can go from every single.
You can go from one vertex to any other vertex. You can go.
Yeah. Indirectly.
But it's not complete because A is not joined to C directly.
Yeah, it's not complete. I said that.
Very good. Correct. Cheapest way to travel from A to D. So what you need to do is you need to explore. So if you go from A, B, D is 60, you need to check. Now if you go anywhere, it will be longer. But sometimes the weights are not proportional. So you need to check all possibilities. And you will find, so suppose you go from A to B, B to C and C to D, that will be obviously more. Correct? So that's how you do it. Simple as that.
So what was your answer you got?
60. You got 57, you said.
Yeah, I got 57.
How? Which one? From A to?
A to F.
A to F15?
No, one second. Yeah.
So check.
Yeah. So we can go up 1 second.
1 second. I'll pull this up. You can check with that. Here. So P to Q. The weight is 3. P to Q is going. There's no connection from P to R. There's no path from P to R, and that's how we draw it.